Hello, students. Welcome to chapter 11 on terrestrial planets Mercury, Venus, and Mars. Mercury, Venus, Earth, and Mars are called terrestrial planets because these are all Earth-like. We have studied a separate chapter on the Earth, so here we'll only explore Mercury, Venus, and Mars. First, let's look at some of the data on the three planets. Uh, Here are a few different distances for Mercury from the Sun. Mercury has the most elliptical orbit, and because of that, there is quite a bit of variation in how close or how far it is from the Sun. Its eccentricity of orbit is 0.206. Its orbital period is 88 days, the time it takes to go around the Sun, and rotation period is 60 days, about 60 days. This creates an interesting phenomena which is called synchronous rotation with the ratio of 2:3. What that ends up doing is that in one orbit around the sun, one hemisphere of the Mercury faces towards the sun, and in the second go around, the second hemisphere faces towards the sun. The mass is 0.0553 Earth mass, or 5% of the Earth's mass. Its diameter is about 38% of Earth's diameter. Average density is 5430 kilograms per cubic meter. Surface gravity is 38%. The number 38 appears in a few places when it comes to Mercury. For example, average distance from the sun is about 0.38 astronomical units. The diameter in terms of Earth diameter is 0.38 Earth diameters. The gravity is 0.38. Its average surface temperature on the day side, it is 662 Fahrenheit, and on the night side, it's minus 274 Fahrenheit, and it has essentially uh, no atmosphere. In trying to think of the properties of Mercury, you could think of it as more like the moon. Here is the data about Venus. Um, its eccentricity of orbit is 0.0068. That means you can pretty much assume the orbit of Venus to be pretty close to a circle. The interesting thing about Venus is that even though it is the second planet from the sun, so you would expect it to be less hot than Mercury, but turns out Venus is the hottest planet in the solar system. And the reason for that is the greenhouse effect. Venus has a very thick blanket of atmosphere which retains heat due to greenhouse effect, and that's why it has a very high temperature. Its temperature is 860 Fahrenheit or 733 Kelvin, which is high enough to melt lead. Venus is also called Earth's twin because it has many properties which are similar to Earth. For example, its surface gravity is 0.91 or 91% of the Earth's gravity. In size as well, it is pretty close to the Earth's size. Then comes Mars. Mars is the red planet. Uh, it is similar to Earth in terms of having its day is very close to 24 hours, and it has seasons as well. Its distance from the sun is about 1.5 astronomical units. Orbital period is 1.88 years. There is a tilt of its axis, just like Earth's axis is tilted at 23.5 degrees. uh, Mars's axis is tilted at 25 degrees. Um, However, its size is relatively much smaller compared to the Earth. Um, its gravity is 0.38. Let's look at the temperatures. The temperature is more moderate. Maximum is 70 degree Fahrenheit. Minimum is negative 63 degree Fahrenheit. Sorry, the mean is, and the minimum is minus 220 degree Fahrenheit. Uh, Atmosphere, it has a very thin atmosphere, which is composed largely of carbon dioxide, then some nitrogen, and then a very small amount of water vapor and some other gases. By the way, if we look at the atmospheric composition of Venus, it also has majority carbon dioxide, second major gas is nitrogen, and so on. All right, so let's talk about viewing Mercury and Venus, when and where you can see them. So the thing about Mercury and Venus is that these have also been called the the morning star and the evening star, and the reason is that they are usually visible uh, before sunrise or after sunset, and it is because of their position in the solar system as being inferior planets. Their orbit is smaller than Earth's orbit, and as you can see from the geometry of how we look at the planets, we see them in the sky pretty close to the sun. So most of the time when the sun is in the sky, these planets are in the sky as well, but they are not visible due to the glare uh, of the sun. Only when the sun, only before the rise of the sun or after the sunset is when we could catch a glimpse of these. And because of that, the other thing is that you should never expect to see Mercury or Venus in the sky at midnight. Um, the greatest eastern elongation of Venus is 47 degrees. So the longest it could appear in the sky before sunrise could be 3 hours, up to 3 hours, and for Mercury, it's 2 hours. Now, Mars, because Mars has an orbit bigger than the Earth's orbit, because of that, um, it can be viewed. Uh, it can be viewed even at midnight and at other times as well. The best time to see it is during opposition. So if the green circle is the orbit of the Earth and the red circle is the orbit of Mars, then depending on where Earth and Mars are, the distances between Earth and Mars could vary um, by quite a significant amount. So the best time to see Mars is during opposition because that is the time when it is closest to the Earth. Also, it is in a position where it can directly reflect the sun's light to us, and also there is no sun's glare. Rotation of planets. Mars rotates um, on its axis in a time period which is very close to the Earth, uh, about 24 hours. Venus is the slowest rotating planet, and it also has a retrograde rotation, which means that it spins in the other direction. Every planet except Venus and Uranus, they all spin in the same direction as the direction in which they go around the sun. Mercury's rotation period is about 59 days. Um, it is interesting that the rotation of Mars was known since 1666 because we can see the surface of Mars and there are features on it. And so its rotation can be observed, but Venus has a very thick atmosphere and Mercury is hidden in the glare of the sun. So it was only in 1960 that we were able to find the rate of rotation of Mercury and Venus. So here is what I was talking about. Um, the rotation period of Mercury was determined using Doppler effect with radar. It has a 3-to-2 spin orbit coupling with a rotation period of about 59 days and orbital period of about 88 days. In the contrast to the expected synchronous rotation or one-to-one spin orbit coupling. One-to-one spin orbit coupling, if you'll remember, is what Moon has. So the rate of rotation of the Moon is the same as the time in which it does an orbit around the Earth. And so that is one-to-one spin orbit coupling, and that causes the Moon to always keep one face towards the Earth. However, 3-to-2 spin orbit coupling of Mercury causes it to face one side towards the sun and then the other side towards the sun by taking turns. And the rate of rotation was determined by sending radio waves and measuring the Doppler shift uh, of the waves after being reflected from opposite sides. Here's a picture explaining the 3-to-2 spin orbit coupling. Rotation of Venus, slow and retrograde. All right, now talk about the surface of Mercury and in general properties of Mercury. So instead of talking about properties of Mercury piecemeal, one at a time, if we can think of a whole model with which to compare Mercury, then it would be an easier way to to understand the properties of Mercury, and that model is the Moon. Um, because of being a small object in the solar system, same as the Earth's moon, there are some properties that are shared both by Mercury and the moon. And these properties are, it has small objects, so it has no atmosphere because gravity is needed to keep the gases attached to the surface. And a small object has less gravity. And in this case, the gravity is small enough that it cannot hold on to any atmosphere. Secondly, small objects have a low ratio of internal volume to the surface so that they lose heat quickly and they solidify, not having a liquid interior. So there's no geological activity. It has old surface. It has no global magnetic field. The magnetic fields of planets are produced by molten interior. And so if there is no molten interior, then there is no magnetic field, same as moon. On the other hand, if there was a large object, it would have thick atmosphere because the gravity would retain atmosphere. It would have internal heat, which would not have been totally lost. So it would have geological activity. It would have young surface, and it would have global magnetic field. For example, the Earth and Venus. Here are some descriptions. So Mercury has lots of craters, just like the moon. Here are some more descriptions of specific features. This is the internal structure of Mercury. Um, so it has these three parts, just like the Earth, starting from the surface going towards the center. Those are crust, mantle, and core. Earth has those same parts. However, the relative sizes of these are different for Mercury. Mercury's core is much bigger. relatively much bigger. So for Mercury, the core is 75% of its diameter. In the case of Earth, the Earth's core is 55% of its diameter. And for comparison, Moon's core is about 20% of its diameter. Now, the core of planets, this is related to something you learned in the chapter on the solar system, chapter 8, and it described how the core of the planets formed by chemical differentiation. So turns out the core of terrestrial planets have iron and nickel, and mostly iron in its core. So because Mercury has such a big core, it is largely made up of iron, and so Mercury has also been termed a ball of iron. There is a theory about why this might have happened. It is thought that at some ancient time there was a collision uh, of the proto-Mercury with another planetesimal, which caused it to melt and vaporize the rocky mantles of the both worlds, and then the remaining metal rich material again coalesced to reform the Mercury. However, there's a surprising thing. So from what understanding we have about the internal structure of Mercury, we think that it should not have a liquid core, which is required for a global magnetic field. However, it has been found that there is a small amount of magnetic field in Mercury, and it is not clearly understood why that is. Let's talk about the speculations about Venus and Mars. For a long time, it was thought that there might be uh, living beings and civilizations on Venus and Mars. Venus was thought to be, before we knew better, Venus was thought to be a tropical paradise with nice tropical beaches. However, it turns out that the temperature is much higher due to strong greenhouse effect of its thick atmosphere. So, because of that, there cannot be any life on Venus. And then Mars was thought to have canals, plant life, even Martians. And this all originated because of a misunderstanding. There was a astronomer Schiaparelli who observed Mars with his telescope, and he didn't get a very good picture, but from what he saw, he imagined there were canals, irrigation canals, and water transport canals made by Martian civilization. And so he drew it in his book, and then inspired by him, many other astronomers observed Mars and counted the number of canals. And so scientists thought that there was a civilization on Mars. Tectonics. Tectonics is the study of crust. So the Earth has plate tectonics, again, something that was studied in uh, chapter 9 on Earth, how the Earth's tectonic plates move around. The Earth's tectonic plates are, there are 10 pieces of tectonic plates or continental plates, and they move around due to moderate internal heat. And so Earth is said to have a young surface. Venus's surface is more flaky because the crust breaks up into numerous flakes, producing a small scale deformation and reshaping the surface again. This is called a young surface, and it is because of relatively strong internal heat. However, Mars has neither plate nor flake tectonics. It has a thick and rigid crust, whole surface. It is due to relatively weak internal heat. Um, the size of Mars is quite small compared to the Earth, and so the internal heat has already been lost. All right, here are some more details that I won't go over right now. This is just repetition and more elaboration of the things we talked about. Here are two pictures showing the difference between plate tectonics of Earth and the flake tectonics of Venus. Mars has huge volcanoes. In fact, it has the biggest volcanic mountain in the solar system, and it is called Olympus Mons. Let's talk about the atmospheres of um, Earth, Venus, and Mars and compare and contrast them. So first thing to note is the temperature variation. So Earth has this very interesting temperature variation, which is starting from the surface going up, the temperature first drops, then it rises, then it drops, then it rises again. So there are four layers: troposphere, stratosphere, mesosphere, thermosphere. And it extends to about 100 kilometers. Uh, when it comes to Venus, its temperature, its atmosphere also extends to 100 kilometers. Uh, but the temperature variation is pretty uniform. Starts out very hot near the surface, about 800 Kelvin, and just keeps dropping as you go higher and higher up. And in the middle, there are several cloud layers and haze layers. And as we'll see, there's sulfuric acid rain that happens in Venus. Here is the atmosphere of Mars, very thin atmosphere of Mars. Um, its temperature also drops uniformly, and in between there are water ice clouds and dust clouds and carbon dioxide ice clouds. Now here is how you can see, I mean, from these pictures, it looks like these atmospheres are very similar, but when you see the pressure, that's what tells you about the difference. The Earth's pressure is 1 atmosphere. The pressure on Venus is 90 atmospheres. It is 90 times as much as on Earth. And the pressure on Mars is 0.006 atmospheres. So that is almost like 1,000, or actually 6 parts in 1,000 compared to the Earth's atmosphere. All right, here's some repetition of the description about greenhouse effect. Venus has perpetual thick clouds. Clouds mainly consist of droplets of concentrated sulfuric acid. So Venus is not a fun place to be. Mars is very cold. Um, the greenhouse effect on Mars is very weak because of very thin atmosphere. In fact, it has a effect which is called ice house effect, which we'll talk about a little bit later. All right, so here is the ice house effect. So usually the atmosphere traps the heat and keeps the planet warm. But what happens on Mars is that in the winter it gets so cold that the ice cap that the carbon dioxide in the air freezes and forms uh, dry ice. And so that the atmosphere is becomes even less dense. And so its ability to trap heat is reduced. So it gets further cold. And that is called the ice house effect. Mars has global dust storms. It has atmospheres. It has the seasons just like Earth because it has a tilted axis. So for some part of the year, the North Pole uh, experiences summer and the South Pole experiences winter and so on. So when it gets hot, then the carbon dioxide evaporates and it uh, has this global transportation from one pole to the other. And this produces global dust storms. Evolution of atmosphere, how did the atmosphere form and evolve? So this is origin of atmosphere on Earth. Outgassing of volcanoes, gases trapped in the rocks but emitted through active volcanoes. So many of the gases came out from volcanoes. And these were primarily water vapor, carbon dioxide, and sulfur dioxide. There's a detailed analysis here, which it is not possible to go in full detail here, but the steps are described very clearly how things happen on Earth, how things happen on Venus, and how they happen on Mars, leading to the different atmospheres of Earth, Mars, and Venus. Obviously, the biggest uh, different thing that happened on Earth was the evolution of life and evolution of plants, which converted the carbon dioxide into oxygen. And Earth has this huge amount of oxygen. Whereas if you look at Mars and Venus, they have about 95, 96% carbon dioxide. But on Earth, that carbon dioxide was there to begin with, but it got converted into oxygen because of the plant life. All right. So with that, we get to the end of this chapter with some questions for food for thought. Oh, here's I guess one or two more points, which is there water on Mars? Well, there hasn't. We have sent our explorers, robotic explorers, to the Mars, and there is no liquid water or rainfall on planet surface today. However, there are various land structures which suggest that in ancient times there was water on Mars. There's also some frozen water uh, contained under polar caps of and permafrost, but there is no liquid flowing water at this time. Here is a history of the various robotic explorers that have been sent to Mars. Right. And with that, we finish this chapter.